All right, so today we're going to talk to you a little bit about neutron activation, or how you can turn something that's normally fine into something that can kill you. Anyway, what we do up here on our 6th floor lab, which is kind of small to bring you all up to, is we've got a artificial radioactivity lab where we use a Geiger counter, or hopefully this thing's coming into view. This tube here, where we supply a large amount of voltage, and there's some gas in this chamber. And what happens is when there's any sort of radioactive event, there's actually kind of a breakdown in the gas that sends a voltage signal that we can read and can count these events. So what we've got over here is one that's up and running. We've got a slightly different looking tube down in there. And we're running about 900 volts across the tube, which is what it's supposed to operate at. And if I don't have anything radioactive in there, what I actually have done is I'm setting the voltage back in through the microphone jack in a computer. So every once in a while, whether it's a cosmic ray or what have you, there is a little bit of background radiation wherever you're standing. Granted, out of everything, if you're sitting in Grand Central Station, is actually about 5 times more radioactive than background. It's nothing to worry about. It's still perfectly acceptable, but some things are just naturally slightly radioactive. So what we can actually do is listen to just the background, and every once in a while you'll hear it click. And what I can actually do is zoom in on that real quick. And you'll actually see this weird little voltage spike. Every once in a while, and I can send some of that in. But you know, it's pretty infrequent. Now what I can do instead is put in this little radioactive oil drop of cobalt-60. It's pretty small, but when I do that, here near the counter, just to give you an idea, this thing is much, much more active than background. So I'm just recording a few seconds and we can stop and listen to it. And with any luck, you're hearing a lot more clicks. So what we've got here is a foil of indium, which right now it's not radioactive at all. And I believe its half-life is something like 400 trillion years, or many, many times the age of the universe. But what we can do is bombard it with some neutrons. So normally, or back in the day, we had some plutonium to do this with, which is kind of scary, and somebody realized we don't need it, so we use americium beryllium instead. And americium blasts an alpha particle into the beryllium, which then releases some neutrons after this fusion reaction. So we're bombarding the indium with neutrons, changing it to a different isotope, and one of them's got something of a half-life that's, I believe, on the order of less than 20 seconds. So what we're going to do is look away if you don't find out what my login is. We've got another indium foil that's currently cooking in here. We're going to pull out. And since the half-life's so slow, I need to move a little quick. But if we get this up and running right away, there's actually some activity in the indium, which you can listen to. Now our regular indium, which we haven't put in, I'm going to swap with that real quick. And that, with any luck, isn't quite so active. So this is kind of more of your background count rate again. I'll be sending some data along to your professor. Okay, good. We've got occasional background clicks, and you can take a look.